Okay, so I believe all of you are aware about your class test too. So yesterday also I have shared this routine that has been provided to us that we have opened. Okay, so through the Google Classroom. So your class test too, if you have gone through the routine, then it starts from 16th of this particular month. Okay, and once again to your like it's a good news, like you are getting whole hours. Okay, as per this timing also it is starts from 9 to 12, and then afternoon session 1:30 to 4:30. So you are getting 3 whole hours for this class test only for 40 marks and all. And we have our manufacturing method just like the last name. So on 17, that is on the second day of this examination, in the first half itself, in the morning half, we have got this particular exam. Okay, so now those who are lagging in your studies and all, I used to tell them that means as your last test is approaching, it's after 10 days, we still have 10 more days. Okay, around 2 cycles. So start studying. Okay, so in the meantime, if you have any doubt, any question, you can ask. Or if no, shall we start? Shall we move ahead, or we shall wait for some more minute to some of your friends to join? Okay, we are going to start then. So from the previous classes, so in the previous classes we have actually discussed about various method of producing internal as well as external traits. So there we have seen the very basic methods like the making external traits by using those dies and all, which may be collapsible dies, or you can say spring adjustable kind of die, or we can have also solid die which cannot be adjusted. That means if we are talking of the adjustable type of die, that means it can accommodate a particular range of shaft diameter on which it can cut the thread. There we have seen whether it's kind of manual method and all the requirement of some lubricants, whether it is fast and all. Okay, so those things we have discussed. Similarly, by tapping also, how we can generate internal threads, what are the requirement prior to going for tapping. Similarly, what are the different sequence in which we do the tapping the process. Okay, so all those things we have discussed. Later on, we have also seen how by using various attachment in different lathe machine, maybe NC, the manual lathe or the CNCs, etc. Also, how we can generate different threads as external as well as internal. Okay, by this method. Similarly, by going for milling attachment in the lathe, also that way also we can do it. Okay, and similarly today we'll be going for some other method by which we'll be able to cut this threads. Okay, so that is basically thread milling. So in the previous case, whatever milling cutter that we have seen, that we have used as an attachment, it was we have used in the center lathe. Okay, and as also we have seen that we'll be able to manufacture or generate thread strip. Okay, threads on it. Now today we are going for this thread milling method. So what is this thread milling method? So this thread milling method, by this thread milling method, we can like very highly accurate threads, basically the larger size. Okay, particularly in larger size are generally a form mill. So form milling means what? So in that particular milling process, basically we are going to use a form cutter. Form cutter means it has got that particular shape of the whatever is the final required thing. Okay, so we can have either a single or a multi-form cutter which can be used in thread milling process. Okay, and in that particular case, so how we generally manufacture thread, okay, or cut thread by thread milling. So if we're talking of a single thread cutter, single form cutter, okay, having a single annular row of thread, it is tilted at a particular angle. which is equal to the helix angle of the thread. Okay, and we already know the threads there. If you look at these figures and all, it will be evident. Okay, that means this thread actually they are tilted by a particular helix angle. Okay, we already know the thread, it is in the form of a particular helix. It owns around this particular, if we are talking of the external, this one is the external threading. So here in the lower figure we are showing about the internal threading. So both the type of threading it's possible in case of thread milling. So in that particular case, what we do, if we're talking of a single form cutter which has got a single annular row of teeth. So this is, if you look at this particular figure, it has got a row of teeth to cut the, or from this particular figure it will be evident. So it has got a row of teeth to cut this particular this thread profile. Okay, so it is generally tilted at an angle which is equal to the helix angle of that particular thread that we are going to cut, and it is fed inward radially. Okay, inward radially means along this part. If it is like external threading, or if it's internal threading, depending on that the position of this particular thread cutter, okay, the form milling cutter, it will be different. So here if we're talking about external milling, so it has to be outside that particular in, or you can say it should be touching the external surface. And if we're generating or cutting the internal thread, then it should be in this way. Okay, it should move inside that particular whatever is the previously cut hole. Okay, so in that case, so it is, as we have said, that it is tilted at an angle which is equal to the helix angle of the thread, and it has to be fed inward radially to its full depth. And in this during that time, initially, that means the work will be stationary, and after that what we do, we start rotating that particular workpiece. Okay, and as well as we simultaneously, the synchronously, we move that particular cutter longitudinally, which is parallel to the axis of the work. So this is, if this is the axis of the work, so the tilting has been done in that particular equal to the helix angle. Then radially we feed it inside, so that up to the full depth. Okay, so that later on when we rotate it, when we give the relative movement between the tool and the workpiece, this cutter is going to cut that particular thread profile. Okay, and during that work, synchronously, depending on what is the speed of rotation of this particular workpiece, or like that. Okay, so depending on that, so the cutter has to be also fed downward. Okay, move downwards, which should, and it should be parallel to this particular workpiece. And for this work, generally we can make user have a lead screw, and until the thread profile is completed at up to the required length, so we'll keep on doing this particular cross. Okay, and in this way, in this particular thread milling operation, so the process, it may be over in a single cut, or we may have to go for suppose different cuts. Okay, multi passes, so starting from the roughing cut to the finishing cut, so as to get the final recut set profile. Okay, and mostly this particular thread milling process, it is generally used for very large lead or multi-lead threads, okay, because we can have a row of teeth on this particular form mill cutter, and that makes it possible to go for a large lead or multi-lead threads. Okay, so here different in this particular figure, an actual process has been shown. Here you can see the thread profile, it is making the external one, and here you can see as the form milling cutter is it is placed inside, so it will be able to generate the internal threads. Okay, and these are the shapes that we have been shown. Okay, so this is about thread milling. So up to this much, I hope all of you are clear. So we have gone through a variety of manufacturing method for your threads. Okay, I think, okay, in the last class, have we discussed thread rolling? I think no, right? Have we gone through the thread rolling process in the last class? Anyone? I think we have not gone through the thread rolling, right? Okay, so apart from this cutting process, so okay, so we also have a very okay, thank you, Manas. So apart from this, so we also have, as we have previously discussed, one of the very important type of manufacturing process for thread, which is basically thread rolling. So if you recall, our when we discussed about the rolling operation, there also we have said that a variety of type of production of different parts, it's possible by different type of form rolling operation. Okay, and what we have discussed in the form rolling, that means we have a particular separate die. Okay, okay, separate rollers, not in it will not be the dice, okay. So and how we basically do that particular case based on that particular shape, okay. Whenever we do the apply the compressive force and all, we can expect that kind of shape profile. So similar is the thing that we are doing here in the thread rolling operation. So thread rolling operation, it's a, once again, as the name itself is there, rolling is there. So ultimately in between two rolls, okay, which are basically the form rolls, that means the shape is already given, the shape profile which will be ultimately required, that will be given. So that is how basically we are going to go for this particular process. So this particular thread rolling process, it's generally is a cold working process, and it is done so as to form the outer surface of a round workpiece, okay. And what is the, as from the name itself, it is evident on that process, what we get, we actually get the form of the threads which is required, and that thread profile has already been given on the particular rollers that we are going to use for the compression purpose. So that's why this particular process, as it is a kind of basically the inherent rolling process only, but for which purpose we are going to utilize it, specifically we are going to utilize it for producing threads. That's why the process name is thread rolling, okay. So what we do here, or how we process move on with this particular process. So now what basically happens, so in this particular case, just like if you can recall all those previously whatever we have discussed during rolling operation, so the main process is somewhat similar to that, and our ultimate goal is to, the shape that we require is, the profile that we require is nothing but the required thread profile. So now in that particular case, it utilizes this process, it utilizes two rotating rolling dies, okay. Why we are using the word die, so basically it has got that particular whatever is the thread profile, that's why it also behaves like somewhat like die. So as, because during the process actually those whatever is the profile that has been given, so positions will be filled up by that workpiece, okay, and it is going to shape conform to that particular shape. That's why we also use the word rolling dice, or sometimes it may be flat die also. But the thing is, it these dies, okay, which can be rolling, so which is evident in this particular figure above, the figure above, it can also be flat die, which is seen in this particular figure which is below, okay. So basically on those particular dies, it has got the external profile of the thread, okay, and which has to be actually which has to be which we want on that particular workpiece, okay. So now during this process, this particular this dice which has already got that particular thread profile, so we utilize this dice so as to exerts dynamic force on the workpiece surface. So the work part, it will be held in between the two dies, okay. You can see in this particular figure it will be basically round workpiece only. So this is one of the view, that's why it looks like kind of flat. But if you look from this direction, actually the cross section of this workpiece will be kind of round. So the workpiece will be round, on which actually on the external diameter of it we are going to produce the thread, okay. So now we are going to utilize this thread rule, this one and this one, where you can see this thread kind of profile. So both the two rolls definitely will be required, as it is a kind of rolling process, and in between it will be having that particular, will be holding that particular part. So there are multiple ways to hold that particular part. You can like we can use the collets and also as to hold that particular part in between, and we can move that particular two the rolling dice, okay. So we can give the rotation and motion to the rolling dice, and by this actually we are going to exert the dynamic compressive dynamic force, okay, on this particular surface on which we actually require the force. Now as the thread form on the rolling die is pressed into the surface of the workpiece, so the whatever is the profile of the thread or the thread form, it is transformed all the way to the root diameter of this particular thread, okay. So already in this particular rules, it may be rolling die, okay, or it may be flat just like that, okay. So ultimately we are going to place this particular workpiece here in between, and we are going to give that compressive force, okay, on this particular workpiece. And during this process, the whole thread form that is there, okay, it is pressed into the surface of the workpiece, and that is transformed all the way to the root diameter of this particular thread, and we get the work done here. That means after the process is over, we actually get the profile of the thread that is impressed on this particular workpiece. Now actually what happens is this particular rolling process a cutting process, just like the previous case where we have discussed. Suppose some chip is generated, we cut that thread profile and all. So no, it's this rolling profile, rolling thread rolling process. It's not a kind of cutting process or machining process. We are not actually getting any wastage and all. Okay, so what basically happens in this thread rolling, actually it is accomplished by shifting the work material by the plastic deformation, just like in the case of some of the rolling operation that we have seen. Okay, so plastically actually the during that whatever highly compressive force that we are exerting through the help of this particular roll, so the at those particular locations, okay, we see, if you think of this particular thread profile, then you can have a heel and plane kind of structure. Okay, you can think of as if in a alternate heel and plane. Okay, crest and like that kind of structure. Okay, crest and valley. Okay, hill and valley, that kind of structure will have. So by that hill location, you can consider as if we are accomplishing, or you can giving the very highly compressive stress, and it is undergoing the work is somehow shifted by plastic deformation. Okay, so in that particular case, so it is accomplished by shifting the work material by plastic deformation, and ultimately that whatever is a shape ultimately that we get, okay, it will remain on the workpiece, and that shape profile, that is nothing but the thread profile that we have obtained. Okay, so that is how we actually go for thread rolling operation. And after the process is over, so the other parts which may not be required, suppose on this particular part only we require a thread profile, maybe it can be hold here and we can do the work here. Okay, and sometimes this particular part, depending on what is the final desired product, it may have to be cut off and all. Okay, so it is just a holding method. So similar is the case. We can have the flat rolling. Okay, the thread profile will be here, and in between them, the circular rope piece will be here. And actually, in this particular case, that is as it is kind of we are talking of the flat die, so we have to give this way translation kind of motion in between them. The relative motion will be somewhat like that. Okay, and in this, if we are talking of the rolling dies, then the dies will be it will be rolling only. Okay, so what are the advantages? So all the advantages which are generally associated with the uh, cold working process, those will also be there in this particular process, because it's basically is a cold working process, cold forming process. So now here, as it is the cold forming process, so the hardness of the thread, it is increased. Okay, because it's a kind of cold forming process. Already we have discussed what happens in cold forming, cold working, warm working, and all. So those advantages are there here also. And as it is basically the cold forming process, and it's a forming process actually, the fiber flow lines, it follows the thread profile in such a way that it has superior resistance to stripping compared to the cut thread. Okay, so here, as we already know, we are actually in our desired directionally that fiber flow lines will be there. So because the fiber flow lines are following the thread profile, so ultimately the superior quality we get in this particular thread. And surface smoothness as well as the accuracy of the dimensional accuracy safety is also more, just like in the case of other cold forming process. And here also another good advantage is there. Most of the metals or alloys, it can be very easily thread roll. Okay, except some very highly brittle material like cast iron, or very soft materials like lead and all. Okay, so this is how very easily and we can get the thread profile done by thread rolling operation. Okay, so with this basically we have covered most of the thread manufacturing operation, internal as well as external. So if you have up to this much any doubt, you can ask, or if no, then we'll move ahead to the manufacturing of gears. If you have understood, you can also let me know. I hope all of you have understood. These are easy things only. Okay, thank you for letting me know. Okay, so next that we are going to next topic that we are going to introduce is manufacturing of gears. So as this particular module has got two parts basically, one is the manufacturing of threads, so which we have just covered, and the next part is basically manufacturing of gears. So just like the requirement of thread manufacturing process, here also we have to have some specialized we have different methods for manufacturing of different gears. So there are a variety of methods by which actually we can make produce gear teeth on various components. Okay, so those the variety of methods which generally are suited for manufacturing of gears, it includes casting method. We can go for forging. We can also go for extrusion, drawing operation. We can go for just like in the thread rolling. We can also go for gear rolling. Also, powder metallurgy. By powder metallurgy, also we can generate gears. About powder metallurgy, we'll be discussing in the next module actually. So next, these are some of the variety of methods by which actually will be we can manufacture gears on various gears. Okay, and apart from that, if we are talking of the making of gears etc. from split metal, then we can go for blanking operation. Okay, so directly on a single shearing operation, we can go for a we can make very thin gears which can be used in different like our clocks, other some simple mechanisms and all. Okay, also it's possible to actually manufacture gears from different other materials like different polymers, plastics, etc. Okay, so for this we can go for molding also, like injection molding, casting, etc. Okay, and apart from these methods which we have discussed, casting, forging, etc., so definitely another versatile method is by machining process. So those also the manufacturing of gears can also be done by the variety of conventional manufacturing processes. It's possible. Apart from that, we also have the different non-conventional machining processes like wear micro ADM, etc. Okay, or Liga. Those are some of the other examples. Liga, we have, okay, laser sintering. All those manufacturing methods are possible by which we can manufacture gears of various sizes and shapes. Okay, shapes means in this particular case we are talking of different gear teeth profile only. Okay, right from the different forming process, machining process, the conventional machining process, to the non-conventional or advanced manufacturing process, all these processes can have the possibilities or applicabilities in producing gears. Okay, so the depending on what is your requirement, okay, whether you what is the metal on which you're working on, what is the accuracy level desired, or what is the size limit. Okay, depending on that you may have to different manufacturing processes might be suitable for different manufacturing of gears. So some of the very frequent machines which are generally used for machining gears are like hobbing, shaping, saving. These are the like most frequently used machines for gear cutting processes which can be utilized in different automotive sectors, in truck, different agricultural sectors, in construction equipments and all. Okay, apart from that, some of the other processes which by which different industrial gears are mass produced, it also includes the broaching process, rolling process, grinding process, milling process, saving, etc. Okay, so now just like we have discussed, so which particular process you are selecting to manufacture gears, it depends on a variety of factors. So one of the factors, just like we have discussed, the metal on by which we are working on. Next, the size of the particular component. Okay, whether that particular process is going to give you suppose like it's whether it's capable of giving if you need suppose micro gears in for using in micro pumps and all, micro recreation and all. So in those cases the process that you have selected, it should be able to like generate that particular, it should be give rise to that particular level of micro feature. Similarly, cost effectiveness, which is one of the very important consideration while we are talking of doing any mass production, or like whenever we are making of commercialization. So in those cases, the process that you are selecting for manufacturing the gears, it has to be cost effective. Otherwise, your competitor may take the advantage, and the particular farm which is producing gears which are not cost effective, okay, which are costly, that means, and giving the suppose similar kind of quality as that of their competitor, it will be soon out of the market. So cost effectiveness of a particular application, depending on how many number of parts you have to produce, okay, production volume, economic consideration, etc., these are very important. Okay, so whenever we are talking of this different type of making gears, okay, so we have to start from a gear blank. Okay, whenever we are talking of manufacturing gears, initially we generally have the gear blank. Okay, and like those are one of the very like versatile metal. Okay, by which basically we generally we manufacture gear. It is cast iron also. Okay, cast iron gears which are very you can say very easily available. Okay, so starting from a rotor cast gear blank, so basically there are two basic methods of making the different teeth of the gear, so which are form cutting and generating method. Okay, so now whenever we are saying of the conventional type of gear manufacturing, we're not right now talking about suppose the micro gears and all. So if in practice in the in mass production or in the industries really, okay, what is the common practice to do the process? So the most commonly used practice is initially we pre-form the gear blank, on which that means that is the gear blank is nothing but the workpiece, okay, the circular thing, okay, by which on which we are actually going to cut that particular or generate that particular teeth profile, okay, required teeth profile. So initially it's the gear blank is preformed by mostly casting method or forging method. So as we have discussed in the forging as well as casting, so this has got the forged part as well as cast part. They have got a variety of they are like the strength requirement or depending on the fiber flow and all. Okay, we have already seen preforming the gear blank by forming process and all, forging process and all. It has got the required grain flow line and all. Okay, so basically the we have to preform the gear blank, and it is followed generally by the pre-machining process to prepare the initial gear blank, which should be of desired dimension. Okay, so initially we produce the gear blank, and then on that particular preformed gear plane, the production of teeth by machining process is carried out. And this particular process, after we produce the teeth on this particular gear plane, actually it is generally followed by the finishing process by grinding method, by grinding or some other or processes like saving and all. Okay, so these gear teeth, which are generally produced by machining. Why we are right now talking about machining? Because machining is processes is these are the one of the very versatile type of like manufacturing process for gears. So the gear teeth, which are basically produced by machining, it is based on two types categories are there. That is the forming. So what is this gear forming? So here the profile of the teeth are basically obtained as the replica of the form of the teeth, that is the shape of the teeth, that is uh, which resembles the form of the particular cutting tool, okay, or the cutting edge. So some examples like in the milling process, in broaching process and all. Okay, these are the gear forming process. Next, we have the gear generation process or generative process for gears. So what is happening here? So in the gear generation, these are in this particular case, so complicated truth profile we can get. Okay, and these are obtained by provided by some simpler form of cutting tools having different required cutting edges through like it may be like rolling type or maybe the giving the proper relative tool and work motion. So this generation process, gear generation process, some examples they include bobbing, gear shaping, etc. Okay, so the first thing that means the gear forming. Okay, where basically we get the replica of that particular form cutter, which we are going to use for cutting that particular teeth. And the next one is the gear generation. So these two are the two basic process which comes under gear machining only. Okay, even though the word is like forming, okay, actually we're talking of some machining process here. Okay, so don't get tempted by suppose if someone asks you gear forming process, okay, and gear generation, so whether they are like forming process, machining process and all, then the answer is they are machining process. Okay, we are cutting that particular treat process. But why the word is forming? Because we are going to use some form cutting tool. Form cutting tool, what is the meaning of the form cutting tool? Form cutting tools are nothing but the cutting tools will be given some particular required shape, which will somewhat resemble the whatever is the final shape that we are obtaining. Okay, so that's basically about form. So up to this much, all of you have understood? Have you understood, or is there any confusion? Have you understood up to this much? So basically, we'll be stopping the class here. So in the next class, we'll be going through these processes. Okay. So different form cutting operation, like form cutting, that is by form milling, then different browsing process, and hobbing, different generation process like shaping, hobbing, etc. Okay, those things we'll go through in the next class. And at the end of this particular module, we'll be going for some like gear finishing process, which includes saving, roll finishing, garnishing, honing, lapping, etc., etc. Okay, so with this, we'll be stopping here for today. And if you have any question, any doubt, you can ask. In the next class, we'll be going through these processes. Today, I have given the introduction about this. Okay. If you have any question, you can ask, or if you have any doubt, you can let me know. Or if you have understood, you can also let me know that we have understood. So seems there is no question. So I hope all of you have understood. So thank you everyone for joining this class. So we'll be meeting in the next class. Thank you everyone. I'm ending the meeting here.